These projects are designed to cultivate multiple skill sets that complement a series of videos created for the purpose of acquiring a foundational knowledge of the Python programming language. These projects will cover coding both console-based and GUI applications. Tkinter is a Python binding to the tk GUI toolkit, and its framework is built into Python's standard library, so it does not require the installation of any additional modules. This makes Tkinter a convenient choice for building graphical interfaces for Python applications. All source code in these videos is available at the 1byte at a time GitHub repository. You will find a link to the code used in each video beneath it, in its description and comments section. You may use these links to download the source code.
This is another small Tkinter project. It's just a GUI calculator, like the one in Windows.
The Python Tkinter GUI.
So if we were to run it, it's just got a basic interface here with some buttons the end user will interact with and the basic mathematical operations. So let's do 5 plus 10. Use 15, and then divided by 2, and then times 20, okay, or 9. Square root would be 3, cube it, 27. Let's do 32 degrees. Fahrenheit, Celsius would be 0, Fahrenheit would be 32. Basic memory method, add to memory. We can recall a memory and then use it in a mathematical operation. So just a basic calculator is all we want to do. But unlike the console calculator we did, the logic for this is very different because it's all based on triggers. It's event-based programming. And it changes the way that we code it. It changes the logic that we have to use, all based on the way that the end user interacts with our graphical interface. And this project will be defined inside of a function. And then down here, we'll just call that method, invoke that method. And when we do, builds our interface and launches main loop, just as we've done in previous projects.
The Python Tkinter code.
There are multiple ways to code a Tkinter project. You can use a class, you can not use a class. You can do it in a function, you can do it in the root level namespace of the script. But in this case, we'll use functions. We have some globals set up, and you shouldn't overuse globals, but there are good reasons to use globals. For one reason, to make your program or application easy to modify and to change things. So you can put those up at the top and quickly and easily change your configuration by loading in something from a configuration file, and that would be like a global, or using global variables. Another reason is when you want a value to persist in memory. Remember, when you're inside of a function or a method, when you call it and that function ends, any variables stored inside that function by default are destroyed. So you lose the values of anything that would be declared inside that function. So you can pass around variables as arguments and parameters back and forth from one function to another, but sometimes you need a value to persist in memory. And for that, you would either want to get into using classes and some type of an inheritance hierarchy, or you want to set up some globals, depending on how big your project is and whether or not you're using classes. So in this case, these globals exist because they need to hold a value. They need to persist outside of the functions in which they're used, okay? And one way of accessing globals, you could just declare a variable in your global namespace in Python, and then you can access that from within a method or class. But another way is you can use this method here called globals, and you can use that to access a global. So all these are declared as globals, but when I want to access them from within a method, so in this case initialize, which is just a method, it's a function I use to set initial values, well, I just use globals, the globals method, and then in square brackets the name of my variable, and I can assign a value to it. And actually you'll see that when you build a Tkinter widget or Tkinter widget, similar syntax. You can assign a value to a variable enclosed in square brackets and assign a value to it after you have built that widget and added it to your frame or to your form, okay? So there's our initialize function. And then this is our calculator GUI interface. It's just a method we want to have that we use to set up the GUI of our calculator, okay? And in this case, we're just building our window here, and we've set the width and the height. We get these attributes, screen width and screen height. We're going to subtract the width from the screen width, the height from the screen height, and then divide by 2. Assign it to this variable appear in the middle, and that'll have our window just appear in the middle. Don't want it to be resizable in either case. It's a fixed size and the background would be white, okay? And this we need, in this case, tk string it's a method to return a string value to a special variable that we're going to use in our interface, okay?
Tkinter widgets listen for events that are triggers, such as a mouse click or key press. When a widget detects its trigger event, it calls its corresponding event handler method.
Next we have event handlers, all right, for our buttons. And then here, down here, let's go ahead and look at where we're defining our interface. This is where we're actually building our interface. So let's take a look at that code and the code to handle it, but first we'll display the interface and see what it does. All right, so here's our basic calculator interface. We have a title in the main frame and window, and then we have, in this case, a couple of text objects to display the output and input, and lots of buttons for the input. So just thinking of a basic calculator, right? Some basic operations, 5 plus 5 equals 10. And here's our expression up here, here's the value here. And then to clear and reset everything, we can store a value in memory, 444. I'll store that in memory. I'll erase it, recall the memory. There's 444, and then let's say I want to multiply it by 2, and then there's the expression, 444 times 2, 888, okay? Let's say that, in this case, I want to get the square. I can get the square root. Let's say I want to cube it, all right? I can cube it. So just thinking of let's say 32 degrees Celsius, 0 degrees Fahrenheit, and 0 degrees Celsius is 32 degrees Fahrenheit. So just added some of those in, and when you click that button, it does the math and performs that operation based on this GUI. So that's our GUI. That's how the end user interacts with our application or with our program. So up here is all of the event handler code, okay? These methods here that will do different things based on what the user clicks. But before we go over that, let's just go over setting up our basic GUI, all right, our basic graphical interface. So here we have some labels and some entry objects and buttons and things. So for instance, here we have a label for expression. We set the border width, and then expressions go here. So it's the very top one at the top that would display the expressions that we saw, okay? We're using absolute positioning, X and Y, the width and the height, just specifying the size. You know, sometimes this can be quite tedious when you're coding an interface, but it's just sort of, you know, trial and error, coding it, getting it to look exactly like you want. You just play with the X and the Y and the width and the height until you get things like you want them. We have an entry object in this case, and then in this entry object, this is, although you can't take input in an entry, we're using it for output because our input really comes just from the end user clicking the buttons of our calculator, right? So that also displays the big number output, whereas the one on top of it displays the expression. So there's our label, there's our entry. The rest of the objects we have to add here are buttons, okay? And notice that each of these has a command. There's a button 7 command, a button 8 command, a button 9 command. So for every one of these, we have to have an event handler. That button listens for an event, and we define that event with the attribute command, and we set the value of it, and it's just a function like any other, although with an event handler method, you would use parentheses, okay? If it were a normal function or a normal method, you would call it with parentheses or invoke it with parentheses. But when it's an event handler function, it's special. You don't have to do that. You don't use those empty parentheses. You just use the function name. So we've got all our buttons here, and just notice that they all have event handler methods or functions, or erase button or clear button. And I'm going to post all of this code on GitHub, so you can get it from GitHub and copy and paste it into Visual Studio Code if you like and play with it, or better yet, type it in yourself. Go do it the long way. But if you're a kinesthetic or a tactile learner, that will help you understand how the code works, and that will help you understand Tkinter and how widgets work in Tkinter if you take the time to code it yourself. Either way, I will make it available. All of these will be available on GitHub. Okay, so what do all these do here? Let's look at the event handlers for them. We're going to scroll up here. Okay, so I have a method key number. It takes as an argument a number. And remember, this is event-based. It's based on a sequence or order of events as the end user interacts with the graphical user interface. So I need to be able to tell whether or not I need to clear values. If they're in the middle of an expression, adding, subtracting something, I need to know whether or not to clear those values or to keep using those values. So that's what I use one of the globals for. If need to clear is true, then I set the value. I simply erase whatever text is in that. And that's this variable here, var output. All right. If I clear that variable, well, what does this go to? Let's go down. All right. Notice here. All right, so if I clear, what am I doing? If I clear this variable here that I've set up, that variable is associated. I'm going to scroll down here. That variable is associated with the text entry object that I'm using to output the variables that the player types in, okay? I set that here with the attribute text variable. So if I get the value of that variable, that essentially it points to, or it links to, that entry widget object. So I get whatever's stored in that entry object. And if I were to clear it, I clear whatever's stored in that entry object. So whatever I do to the variable happens to that entry object there. Just wanted to show you that. Okay? So that's when I key a number. And then what am I going to do? I'm going to grab that input from the entry object as a string value using the get method here. Oops. I'm going to store that in current value. And then I'm going to take the var output, right? Remember, that points to the entry object. So whatever I do to var output is therefore done to the entry widget. And I'm going to set the current value to the number. Okay? And the number was what? It was what was passed into key number, okay? And then if globals add space is true, well, I'll add a space, all right? I'll, take that lab expression box above. I'm going to use cget to get the text, and then I'm going to add a space into the number. And then I don't need to add a space after that, so I'll say false. And then elif, okay? The other possible condition, if add space evaluates to be false, then in this case, I'm just going to take whatever's in that text box and add it to the number. The rest of these, they all call key number itself. Well, here's key number. So the event handler methods, if I click that button, it'll pass in the number that corresponds to the text that's on the face of that button, or the title label part of that button. So 7 is 7, 8 is 8, 9, and so forth. All the buttons here just pass in a numerical argument to the function key number, and then key number takes care of processing, converting it from the string value, and then building up a string, and then adding a space if it needs to add a space, or not adding a space. And I coded it that way. We could have put all of the code in these individual event handler methods if we wanted to, but that would have been a lot of repetitive code, a lot of reinventing the wheel, and there would be no reason to do that. It's much less code if we do it this way, and then we simply pass in a value based on the trigger, whatever button the end user clicked, okay? And then here, if they clear it, we're just going to clear the value of their output, which essentially clears the entry widget object, okay? And the expression, we're also going to clear. We're going to set text to null, right? To nothing. And we're going to call the initialize method, which remember up here, that just initializes our globals. Here's the initialize method, and it initializes all of our globals up here and resets them back to their initial default value, which we need to do every single time we click CE, all right? Every time we clear, okay? Then here are some operations for add, subtract, multiply, and divide. And what do? Again, to save code, right? To minimize the code so we don't have to reinvent the wheel or needlessly have repetitive code, we just pass arguments to a function that we call calculate. And then that method will take whatever parameter or argument is passed into it, and it will handle performing the correct mathematical operation based on the numbers. And let's take a look at that. So here's calculate, okay? And calculate takes in op, and it was just a string value. So add, subtract, multiply, divide. And then in this case, it sets the global operation to the argument we pass in to op. Add, subtract, multiply, divide, whatever it is that we pass in. And then it sets add space to true, and that's for the entry box up top, so that it will add a space when we're displaying the value in the box beneath it. That's just a number, but up top we're trying to display the whole expression of what the end user is doing with the calculator. So for that, we need this global, and we turn it on and off. We set it true and false based on what part of the expression we are at. Based on how the end user, is it the first time they click the number, and then they click an operating button, and then they click the second number to add, subtract, multiply, or divide, or is it the first time? So that's what this global is doing right here, okay? And we want to get the value of what we have in that object and store it in the number, okay? And if globals is next expression is true, okay, and in this case, we don't want to do this on the first number, right? We want to make sure that we've got to have two numbers, two different values to do some sort of mathematical operation on them. So we're looking to see whether or not they clicked equals. And if they clicked equals is false, then what are we going to do? Okay, the number 2, that number, we're going to convert it, all right, to a float. Why a float? Well, we can't do math with a string, okay? And that number, at first we get it from the var output variable in an entry or a text widget. Well, that comes in as a string, and you can't do math on a string. The string 3 is very different from the actual number 3 computationally. So in this case, we need to convert it. So we would want to parse it or convert it to an integer or a float. In this case, a float, so that way we could handle decimal point numbers, 3.14 or 2.7 or something. If we were going to parse it or convert it to an integer, then it would truncate the value, and we would lose the decimal portion of anything that we were doing math on. So that's why we want to choose float in this instance. And we convert the string, which we got from var output, now to a float. And we store that in number 2, okay? And again, these globals, because as we call these methods, these functions, intermittently back and forth, we don't want to lose the value. When calculate ends, we're going to call it again. It could be a multiple term expression, and we don't want to lose the persistence of the value of that variable in memory. So we're assigning it to a global, and that way we can call this function several times, and we can accumulate or maintain or keep or do math on some number previously entered, and we won't lose the value of it when our function, our calculate method, comes to an end. So here and calculate, we just take the argument op, and this is whatever, add, subtract, multiply, divide, and we set the global here, because if it's a multiple number expression, or if it's a series of calculations in an expression, then we need to allow that to persist in memory, as we might call calculate and other functions several times before we get to the end result, or before the end user clicks equals. So again, that is stored in a global, although it's passed in as an argument. And then whether or not to add a space, in this case for the Tkinter object up top, yes, we need to add a space in the expression for the next part of the expression. So that's set to true. Then we get the string value, okay, of whatever is in that entry object using our variable here, var output get, and we store that in the number. Okay, so in this case, here we say if globals clicked equals is false, right? So they haven't clicked equals yet, they're still building their expression on the mathematical operation. Then what we want to do is, if we pass in as an argument, addition, subtraction, or multiplication or divide, if that comes in as an argument for op, based on that, the button they clicked, then we'll do this. We'll take the global and we will, add it to the next number in the expression. Now, we need to parse or convert that, because remember, if we use the get method on an entry or text object, it comes in as a string, and we can't do math on a string, but we can do math on a number. So we have to parse it, convert it to either an integer or a float. In this case, I'm converting it to a float because I don't want it to truncate or lose any decimal values. I want to be able to add, subtract, multiply, divide, 3.14 or 2.7, and not have it just shave off that everything to the right of the decimal, which it would if I converted it to an integer, just round it to a whole number value. So float is a bit more precise, although it does consume more memory. And then we'll simply perform that operation, right? Once we've converted the strings to numbers, floats that we can actually do some math on, we'll add, or we'll subtract, or we'll multiply, or we'll divide. Now, division is a special case as far as a mathematical operation, because remember, in programming, we don't ever want to get our application to divide by 0. That will generate errors, throw exceptions. So just a little bit of bulletproofing here. And this calculator app is by no means completely bulletproof. There's still plenty of ways the end user could crash it by doing the wrong thing at the wrong time. We haven't handled all the contingencies that we need to, but one of the things we could look for is, hey, if the second number in the expression, once it's converted, evaluates to be 0, then let's just set the first number to be 0, okay? And that way we won't be dividing any value that's non-zero by 0. And that we can get away with. Else, as long as it's not 0, if it's any other number, we'll go ahead and carry through with the division, okay? And let's see how that works real quick. If I launch the calculator, all right, 5 divided by a non-zero number like 2 is how much? That's 2.5, right? Now, if we didn't add that little bit of bulletproofing, it would crash on us. So here I can do 5 divided by 0 is equal to, it's just 0, because I've coded for that possibility. I bulletproofed it just a little bit for that contingency, right? What would happen if we didn't do that? Let's take a look, and we will, let's just get rid of this whole contingency here. Okay. Now let's see what happens. Matter of fact, let me clear this down here. Okay. Let's run our application. And 5 divided by 2 is, it's still 2.5, no problem there, but without coding for that, without preventing them from dividing by 0, what would happen if we let them divide by 0? See, down here, 0 division error, float division by 0. So that would be an error. So we want to code for that possibility. We want to be able to handle that type of error. And we can do that with just a simple if and else logic structure right there. Okay. And then in this case, I want to set the value, right? And I'm going to set it to the value of number 1. And if I do that, var output, remember it points to my text entry widget. So if I set that to be anything, in this case, the global number 1, then it's going to be converted to a string and then it'll be displayed. And then need to clear will be true because I need to clear the expression at that point. And then final output, if it's false, then what am I going to do? Then the lab expression text is going to be the number plus a space plus the operand, addition, subtraction, multiply, or divide. This is to build up the expression in that label object up top over the entry object that we're using to display our main numbers. Otherwise, the final output is true. Then I'm going to take whatever's there, cget, the text, all the text that's in the current expression, and I'm just going to add the assignment operator, and then I'm going to convert to a string number 1, because whatever's done in the mathematical operation here, right, we're assigning it back to number 1. So number 1 just takes whatever mathematical operation was done with numbers 1 and numbers 2, and then overwrites it and stores it back in num1. So we're getting the most use out of that variable. We're just reusing that variable, and I'm converting it to a string here. And then I set final output to be false. And then if the global is clicked equals evaluates to true, then clicked equals, if it will be set to false. So this just toggles on and off like a light switch, whether or not they've clicked equals. This is all event-based input. So your logic has to change. It's not the same as coding a console application where you would run everything inside of a loop and you could control what you let the end user have access to. In this instance, they have access to any random sequence of buttons they might choose to click. So you have to change your logic accordingly. An application with GUI, the logic is very different from a console application because it's based on how the end user interacts with the GUI interface and not how you control their access to it as if you were coding an application that only ran from the console. It takes a bit of getting used to it first. You have to think in a different way. Your logic has to work in a different way. You have to think of everything in terms of events and triggers and not just what you want to happen in a straight up loop or block of code when you get into GUI or event-based programming. Okay. And then everything here, all right, if his next expression is true, if not, then what? Well, we're going to parse or convert the string value and assign it to our global. Need declare is set to be true. His next expression is set to be true. And the label expression will be set to the number and a space and then the operand. Add, subtract, multiply, divide. Okay? Now, and this is just math equals. And what happens in math equals? Okay? So final output is set to be true. And then calculate is the operation. Need to clear true and clicked equals false. And where does that get called? That's when they press the equals button. So again, you have to think of the sequence of events, right? They click on a number. All right, that's one event. Then they click on an operand. They want a certain mathematical operation. That's another event, another trigger. Then they click on another number. That's another event or another trigger. And then they might click on another operator, another operand, and then they might click on another number. So you have to think sort of in those terms. And then in this case, clicked equals, it's true because they clicked equals. And that will set up the sequence between our globals and our locals and our booleans and our numbers and our strings to set up our calculator interface or app to be ready for the next operation, okay? And then down here, when we load the app or the window, we're just calling the initialize function to set the initial values. And in this case, in the label, we're clearing it. In case anything was there before, we're going to clear it. Actually, the first time running the app, we don't even need that, but here we'll just do that. And then, as with every Tkinter application, you're going to run it inside of a main loop, all right? We don't need any threading in this case because we're not playing sounds or videos or doing looping. But remember, if you do that in a Tkinter application, and actually the same thing happens in an MFC application with C++ or a Java application when using JFrames. You don't want to do CPU intensive things inside the main loop. Every window of an application in Python and Java and C++, they all run inside of a main loop. And so you want to get into multi-threading if you're going to do things like play sounds or play media clips or have other functions that are looping and calling other methods. Because if you don't do those in a separate thread, if you do them inside the main loop in that thread, it'll lock up your GUI interface. And it'll freeze up and the end user won't be able to interact with it while they're doing other things. But we don't need that in this case because we're just doing mathematical operations when they click the buttons. There's nothing here that we really need to use multi-threading for. You could, but in this application, because of its simplicity, we don't need it. And here we're just going to invoke, all right, the method or function that builds our graphical interface. So here it is being invoked, and up here it is being defined, okay? And that's all our code. This is all on GitHub. So, you can go through the code, kind of see how it works, what it does. You'll see what I mean. If you are, if you haven't coded many graphical applications and you're learning Tkinter, you'll understand by doing different projects like this one that your logic has to change. The way you code has to change for an event-based graphical application, a program that uses a GUI. It's a whole different type of thinking than when you code a console application. And we'll run this one more time here and go through some basic operations. 8 times 8, 64. Let's add that to memory. Let's clear it. Let's recall that memory. And then let's cube it. All right. So 262,144. And let's square root it. 512. Let's square root that. 22.627. And let's convert that to Celsius. -5 Celsius. Let's convert it to Fahrenheit. 22 point. Just, again, we're going through different things, different parts of it. Let's do 2.6 plus 3.2 equals 5.8000001. Again, because it's a float, so it's calculated to that much precision. And here's our expression up here. So we're just playing with different operations, and at least we did code a little bit of bulletproofing here so that if they tried to divide by 0, we just set it to 0. Anything divided by 0 in mathematics, we just say, hey, if it's divided by 0, it's just 0. Well, we know that, but that's, mathematically we don't want our application to do that. So we just bulletproofed it a little and coded around that. And a multiple expression, 2 plus 2 plus 2 plus 2 plus 2, 10, see? So again, because of the way we coded it, we can handle multiple values, multiple mathematical operations in our expression builder, just as a real calculator would. But the logic, the way we code it is much different than a console app because of how the end user interacts with the graphical user interface. And you will find that to be true with every single Tkinter application that you code. If you're used to writing applications for the console, your logic, the whole way that you think, the whole way you approach coding is about to change.